Hey, what's up guys? Welcome to today's video and we'll be continuing our machine learning tutorial series, and today we'll be doing support vector machine over Python. So let's go ahead and see the definition. As it shows that support vector machines are learning algorithms that try to find a hyperplane that separates the differently classified data the most. Now guys, as you can see, there are some data points in blue and green. Now in support vector machine, what's preferred is the data points that are far off from the center, from the line that's drawn, and those data points are basically called support vector machine, as the name says, support vector machines. Okay, so let's go ahead, and now basically you have some fine-tuning methods just in case you want to increase your accuracy score and make the model perform a bit better, right? So you've got gamma regularization that's represented by C, which we'll be doing that as well, and kernel. So whichever one you want to use depending on the situation, you can go ahead and use that. So I'm going to go ahead and I'll take you through the code that was done over on Python. Let's go ahead and check that out. Okay, now that we are on the code of the support vector machine that's been done on Python, I'll basically walk you through. So I imported some libraries such as Panda, NumPy, and Matplotlib for the graph. Now we're basically using a dataset from the sklearn dataset module, and that's the digits, load digits. All right. So I'm basically going to see what the features are in that. So I'm going to show that to you, and the features are shown out here. So we're checking this out. Now I want to as well show you that what exactly is this data set. So let's say I'm going to call 4 and we're going to see it out. Okay, so the image is shown here. Perfect. So this is showing us a 4. Alright. Now let's go a bit on, just comment this out. Okay. Now I want to check out the target names as well, as in like what is in this target names. Alright, so let's check that out. Okay, we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is absolutely correct, what we were looking forward to. Now basically I'm going to separate this data set and I'm going to get 20% to testing and 80% to training. So from sklearn model selection, we're going to import the train test split, and we're going to basically just simply split it. Now I want to check the length as well of xtrain and of xtest. Okay, and I want to see if it's coming accurate. So I'm just going to do the numbers, my subtraction as well, and yeah, this is correct. So we got the length as well. Now what we're going to do is that I'm now going to train the algorithm. Alright, so from sklearn.svm I'm going to import svc. Alright, now I made the model as well, and I'm going to train the model with xtrain and ytrain. Okay, now as the model has been trained, we want to evaluate the algorithm as well. So for that I'm going to check out the score, that what's the accuracy score, and it shows 0.9833. Alright, that's really good. So I'm as well now going to make a prediction as well. Let's just show it further, like, to see how it shows. Okay, so I basically put 55 and it showed me 0, but now I want to do is I want to fine tune this. Alright, the accuracy score. So what first I'm going to basically remove the comments out, and we're going to run together and we're going to see which one is actually better. So as I mentioned earlier, that we will also be doing some fine-tuning methods. That's going to be kernel, and you got regularization, then you got linear, RBF, and gamma. Right, so you just hang them, just checking this out. Yep. So now all has been done. Now I'm just going to go ahead and we're going to check this out. Now first for kernel linear, basically you got model linear underscore kernel. Alright, and I add the svc and I use the kernel of linear. Alright, I use this parameter linear, the kernel parameter, and we got fit. We use the fit method and we put xtrain and ytrain. Right, and now we're just going to just print the kernel score as well, and the same we've done for RBF, where we use the parameter of RBF. For regularization as well, we use default. The default is set to C equals to 1, right? This is default. Now I'm going to increase the regularization and I put C equals to 10. We'll check this score as well. And as for gamma, I've added 10 just to check it out, and we fit it as well, and then we train it and we'll see the score. So I'm just going to run all of this together and we're going to see which one provides us a better score. Okay, so as you can see, the kernel with linear, it gives us 0.96, then it goes from RBF gives us 0.97, then the default regularization is 0.97, increased regularization gives a slight increase, and gamma gives 0.75. So which one do you think we should actually go forward with? You can actually comment down as well. in the comment section. And guys, this is a tutorial for support vector machine. If you guys have any question, please comment down as well. I'll get back to you. And I hope you have a great day. Thank you so much for watching.